Okay, here's how you find an inverse. First of all, in creating inverses, really what you're doing is you're trying to find a function that would uh, that when given a range value takes you back to the x value that it came from. So in other words, you're going to take your function f of x and you're going to switch the range and domain, then algebraically take the steps to find that variable. So in other words, I start with this, switch x and y, and then look to see what happens. If I want to solve this for y, then those steps will bring me back to the y. And those steps will record the algebra necessary within the formula that I finally get. So I'm going to minus a 3 and divide by 2. So y will be equal to x minus 3 over 2. This we will call f inverse. Okay, now, so again, the whole purpose of the inverse really is to take the values, the y values that are generated by the function f, and map them back into the x values that they came from. This formula will do that for us because it has, we have taken and switched our domain with our range, and then taking the algebra to go backwards to that y value. So in a sense, it's like we're given a y, and we're going to try to solve it for the y value, in a sense for the x value, and then we're calling that y. I mean, we could have solved this for x and then switched it to y. But the point is, we're trying to undo whatever this algebra did here to the value x by isolating it, and then we call that then the function y. So we're switching domain and range when we form an inverse. Now let's look at the graphs of these. Up here I have the 2x plus 3 graph, and I have these two ordered pairs, 0, 3, and this one down here, which is negative 3/2, 0. Now forming the inverse basically switches the domain and the range. So if I take these two pairs, here's 3, 0, and 0, oh, here's 3, 0, and 0, negative 3/2 would be about here. And I connect those, you'll see a graph of the inverse. Okay, so there they are. And something you want to notice about this is it appears to be a reflection over this line y equals x. That's what you're always going to see with two inverse functions that are inverses of each other when they're graphed. There's a symmetry over this y equals x line. So whatever you see here, you see it's like a mirror image flipped over. Okay, remember we had symmetry with respect to the y-axis and so forth. Well, this is symmetry with respect to the line y equals x. Okay, so basically it was saying is that if you replace in your original function, if you replace the x with the y and then try to solve it, you'll get to the other function and so forth. I mean, that's basically what we did when we created this right here, when we switched the x and the y. These steps in here are just to solve it for y and write it as a function of x. The actual inverse was created right in this step right here. As soon as we switch to x with y, you've created the inverse. Whether or not you can solve it for y is another story, but you've created the inverse as soon as you switch x with y. Okay, another thing I wanted to say about this before we move on is that inverse function, again, it undoes what original function did to value x. For a simple function like this, with only a couple things that were done to x, the first thing that was done in order was it was multiplied by 2. So multiply by 2. Second thing, you were adding a 3. So I'll say a3. So that's what f does. Notice what f inverse does to a number when you put it into the function. First thing you do is you subtract 3. Okay, according to this, x is put in here, then you subtract 3. Then the second thing you do is you divide by 2. Notice the operations are in reverse order and they are the inverse operations. So if f does this, then f will undo it by, notice, instead of, so if you did this to your function, if you did this to a value x, to undo it, you would have to take reverse order. First, you would have to subtract the 3 that you added, and then instead of multiplying by 2, you would be dividing by 2 next. So f inverse undoes what f of x did to the value x. So it takes you backwards to where you came from. Okay, that's what f inverse does. And we can do this. We can write our function according to this, but it's difficult to do when there's several operations that are happening at once. So that might be too difficult to follow. So we depend on this mechanical process here of finding inverses, where we first switch the x and y, and then solve for y. That's the more methodical, efficient approach. But you can see conceptually what happens with two functions that are inverse of each other. I just wouldn't want to do this for a complicated function.